So section 1.3, we start to factor with three terms. In section 1.1, we did GCF factoring. In GCF factoring, it doesn't matter. You could have any number of terms. In section 1.2, we did grouping factoring, and that's only used when we have four terms. In section 1.3, each of the problems is going to have three terms. So the problems start with three terms. And we're going to learn two strategies to factor the problems in section 1.3. One of the strategies is to change the problem from a problem that has three terms to a problem that has four terms. And factor by grouping, because once you have four terms, you can factor by grouping. This strategy for this section, it's kind of inefficient, but it works. And the other strategy we're going to learn in this section is template factoring. In this section, the problems have three terms, but I'm going to say the first term, or the lead coefficient, is a 1. So all the problems in section 1.3, the first term is going to have an implied 1 in front of it. And these strategies will work for those problems. As we get into section 1.4, we're going to factor with three terms and the lead coefficient isn't 1, and then, maybe we'll use a different strategy. But to start section 1.3, the first 28 problems start off and they give me a polynomial with three terms, lead coefficient of 1. There's not a number in front of the squared term. The squared term is the lead term in most of these problems. And I'm asked to rewrite the problem with four terms, if possible, and then factor by grouping and check your answer. And finally, I'm going to be able to make a comment about state if the polynomial is prime. So how do I do this? For each of the problems between 1 and 28, I'm going to look at the last number and I'm going to write down its factors. The last number in problem 2 is positive 6. And I need to write down the numbers that multiply out to be positive 6, which I have on this sheet, I think. No, I don't have them because it's too small of a number. The factors of 6, 1 times 6 is 6, and 2 times 3 is 6. Technically, negative 1 times negative 6 also multiplies to 6, and negative 2 times negative 3 also multiplies to be 6. Because the problem doesn't have any minuses to start, I'm not worried about the factors that multiply to 6 that are both negative. But each one of those are going to multiply to 6. So I start off by looking at the last number, and then I start looking at the middle coefficient, the coefficient in front of the middle term in the problem. I'm going to look for the factors of 6 that add to that middle number. So I'm going to look at the factors of 6 here. 1 and 6 is 6. I'm going to add those in a second. 2 and 3 multiplies to 6. I'm going to add those in a second. Negative 1 times negative 6 is 6. I'm going to add those in a second. And negative 2 times negative 3 is 6. I'm going to add those in a second. I don't really need to do all this, but for the first problem I want to. When I add 1 and 6, I get 7. When I add 2 and 3, I get 5. when I add -1 plus -6, I get -7. And when I add -2 plus -3, I get -5. I look at all the factors of 6 and I find the pair that adds up to the number that I pointed at in the middle, 7. So these are the factors of 6 that I'm going to need. What I'm going to do with the 7x is I'm going to use the 1 and the 6, the 1 and the 6 that multiply to 6 and add to 7, and I'm going to rewrite the 7x as 1x plus 6x. Because 1x plus 6x is 7x, I'm going to start off, I'm going to take the problem that started with 3 terms, and I'm going to rewrite it with 4 terms, doing a 1x plus 6x. I could do 6x plus 1x, it doesn't matter. So this is equal to the line above it, because if I simplified by adding the 1x and the 6x, I'd get the 7x. So after I rewrite the problem with 4 terms, I've turned a problem that I don't know how to factor into something that I know how to factor, because when I have 4 terms, I can factor by grouping, and that's what we learned in section 1.3. So in this section, we're going to start off by taking the problem with 3 terms, changing from a problem with 3 terms to 4 terms, and then we're going to factor by grouping. So let me now factor by grouping. I'm going to insert my parentheses around the first 2 terms and around the second 2 terms. From the first 2 terms, I'm going to factor out a common factor of an x and be left with an x plus 1. From the second 2 terms, I'm going to factor out a common factor of a 6 and be left with an x plus 1. I have my choice and directions to write my answer. I could either write the common parentheses first, followed by what's in front of the common parentheses, or I could write what's in front of the common parentheses first, followed by the common parentheses. I claim I'm done, and both of these are correct answers to problem 4. Problem 2. I should be able to check real quickly. Let me show you that my answer works. I'm going to take one of my answers, x plus 1 times x plus 6, and I'm going to multiply by foiling. I'm going to multiply x times x. I'm going to multiply x times 6. I'm going to multiply 1 times x, and I'm going to multiply 1 times 6. When I do this, I get x squared plus 6x plus 1x plus 6. That's 6x and 1x just in an opposite order. I'm going to combine these, and that'll give me the 7x. That's x squared plus 7x plus 6. Because that matches identically the original problem, then I know that my answer is correct. So this is going to be what we're going to do for each of the first 28 problems. However, I want to be more efficient in picking out the pairs by helping you with a template to help me figure out what signs the pairs need to have. In problem 2, the original problem had signs of plus and plus. So if the original problem, if the first sign is a plus and the second sign is a plus, the factors that I'm looking for have to both be pluses. So when I split the middle term up, I'm going to get a couple of pluses. When I move on to number 4, the original problem, the first sign is minus, the second sign is plus. When I go to figure out how to split the middle term up, I'm going to look for the double negative sign. So I'm going to look for double negative numbers that multiply out to be the last number. Eventually, I'll get to problems that have a plus first and a minus second, and a minus first and a plus second. I'll get to those in a second and make some comments about those as we get to them. So just to be efficient, I'm going to not hunt down all the factors. So in problem 4, when I go to work on it, I'm going to try to find the numbers that multiply to 6, it's actually going to be the double negative factors of 6. So numbers that multiply to positive 6, and they have to add to negative 7. I'm always trying to multiply to the last number and add to the middle number. So when I look at problem 4, I'm going to try to find the double negative numbers that multiply out to 6. The double negative numbers that multiply out to 6 are negative 1 and negative 6, because negative 1 times negative 6 is positive 6, and negative 2 times negative 3 is also positive 6. Now I'm going to add these. I'm going to go negative 1 plus negative 6, and I'm going to do negative 2 plus negative 3. So I first find the pairs that are potential ways to break up the middle term. They have to multiply the last. Now I'm going to add these. I'm going to do negative 1 plus negative 6. When I add those, I get negative 7. That's the pair I'm going to need. Or negative 2 plus negative 3. That's not the pair I need. That's going to be negative 5. So what I'm going to do is take this negative 7x, and I'm going to rewrite it as negative 1x. Instead of plus negative 6x, which I could do, plus negative 6x, that's funky. I'm going to write negative 7x equals negative 1x minus 6x, because plus a negative is the same as a minus. So now I'm going to rewrite the problem with 4 terms. So this strategy for problems 1 through 28, I'm going to take a problem that has 3 terms. I'm going to find numbers with the proper signs that multiply to the last number, that add to the middle number, and then I'm going to break up the middle term. So I'm going to rewrite problem 4. In either order, I can do x squared minus 1x minus 6x plus 6, or I could have done x squared minus 6x minus 1x plus 6. Both of these, if you simplified by combining the minus 1x and minus 6x, you'd get that minus 7x would equal to the line above it. Now that I have the problem split into four terms, I'm going to factor by grouping. Put the first 2 terms in a parentheses, second 2 terms in a parentheses, the second 2 terms I capture that negative. From the first 2 terms, I'm going to pull out a common factor of x and be left with an x minus 1. Second parentheses leads with a negative, so I need to factor out a negative. The common factor is 6, so I'm going to factor out a 6. I could do this side, but I'll get the same answer other than my parentheses might be flip-flopped. Now, the common factor of negative 6, I flip the negative sign to positive. I divide the 6 by 6 and left with a 1x. Flip the positive sign to negative, divide the 6 by 6 and get 1. For my answer, I'm either going to write the common parentheses first, followed by what's in front of the common parentheses, or I'm going to write what's in front of the common parentheses, followed by the common parentheses. They're equally correct answers. I could check both of them. They'll check both perfectly. So let's do number 5 together. And number 5, the original problem has double plus signs, so I'm looking for plus plus factors. So when I go to number 5, I'm going to look for numbers that multiply to positive 4 and that add to 5. It's always multiply to the last number, add to the middle coefficient. The factors of 4, 1 times 4 equals to 4, and 2 times 2 equals to 4. I'm not worried about the double negative factors because they're not applicable here. Now I'm going to add the numbers. 1 plus 4 equals to 5. 2 plus 2 equals to 4. This is the pair I'm going to need because they both multiply to 4 and add to 5. So I'm going to take the 5y that's given to me and I'm going to rewrite it as 1y plus 4y because 1y plus 4y is 5y. So I'm going to take the problem that had 3 terms, y squared plus 5y plus 4, and change it to y squared plus 1y plus 4y plus 4. Now I have 4 terms I can factor by grouping. And when I factor by grouping, I put the first two terms in a parentheses, the second two terms in a parentheses. From the first two terms, I'm going to factor out a y and be left with a y plus 1. From the second two terms, I'm going to factor out a 4 and be left with a y plus 1. If you don't get a common parentheses, you didn't break it up properly. Now I'm going to write either the common parentheses first, followed by what's in front of the common parentheses, or write what's in front of the common parentheses, followed by the common parentheses. They're both equally correct answers. Seven and 8, the signs are minus and plus. So I'm going to be looking for the double negative factors. So when I do number 8, I'm leading numbers to multiply to positive 4 and add to negative 4. The double negative, I need the double negative factors of positive 4. Negative 1 times negative 4 multiplies to be positive 4. Negative 2 times negative 2 multiplies to be positive 4. So those fit the multiplying, and now I'm going to add them. I'm going to do negative 1 plus negative 4, and I'm going to do negative 2 plus negative 2. Negative 1 plus negative 4 is negative 5. And negative 2 plus negative 2 is negative 4. So the pair that I need, these are the pair that multiply to positive 4 and add to negative 4. I forgot to write the negative. Now it doesn't really show up, but that's a negative 4. So what I'm going to do with the negative 4y is I'm going to write it as negative 2y plus a negative 2y. And again, that looks weird. Plus a negative is the same as a minus. So I'm going to write the negative 4y as negative 2y minus 2y. So now I'm going to rewrite my problem. It starts off with three terms. I'm going to change the minus 4y into minus 2y minus 2y. Keep the plus 4, and now I'm going to factor by grouping. Put the first two terms in a parentheses. Put the second two terms in a parentheses, shoving the negative in that second parentheses. Common factor here is y. I'll factor out a y and be left with a y minus 2. Need to factor out a negative because that second parenthesis starts with a negative and the common factor is 2. I switch the negative sign to positive, divide that by 2, be left with a y. Switch that positive sign to negative, take the 4 and divide by 2 and get 2. And then for my answer, I write the common parentheses first, followed by what's in front of the common parentheses. Here I get two identical parentheses. I could write my answer, I can't really flip-flop them because they'll look the same, but I could write my answer with one of the parentheses with an exponent of 2. All right, let's do 9 together. For 9, the signs are plus and plus, so I'm worried about plus plus and not worried about any minuses. I need to find the factors of 36. So I need to find numbers that multiply to 36 and add to 13. This is when I'm going to have to pull out my sheet. So I need the factors of 36. The factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. So, just real quickly, 1 times 36 equals to 36. From my sheet, 2 times 18 equals to 36. 3 times 12 equals to 36. 4 times 9 equals to 36. And 6 times 6 equals to 36. Those are all the numbers from this sheet here that multiply to 36. I need now add these up. 1 plus 36 equals to 37. 2 plus 18 equals to 20. 3 plus 12 equals to 15. 4 plus 9 equals to 13. And 6 plus 6 equals to 12. I'm going to need this pair because those are the pair that add to 13. So the 13z, I can either write it as 4z plus 9z, or I can write it as 9z plus 4z. My algebra will look different if I flip-flop the order, but the answer is going to be the same regardless. So let me rewrite the problem as z squared, and I'll just go to plus 4z plus 9z plus 36. Introduce my parentheses. First terms, I'm going to factor out a common factor of a z and be left with a z plus 4. Second two terms, I'm going to factor out a 9 and be left with another z plus 4. I'm doing the common factors quickly because I think you can do them. Pause the video if you need some time to think about that. And now I'm going to write the common factor of z plus 4 followed by what's in front of the common factor z plus 9. That would be a correct answer. Equivalently, I can write z plus 9 times z plus 4. I haven't been checking much. Let me just check this to show you that it checks. If I want to check, I should take my answer, either version of it, z plus 4 times z plus 9, and clear the parentheses. I'm going to multiply z times z and z times 9 to start clearing the parentheses, and 4 times z and 4 times 9 to finish clearing the parentheses. The z times z is z squared. The z times 9 is positive, so I'll put a plus sign and then a 9z. The 4 times z is positive, so I'll put a plus, and the 4z is there. That's the 4z and 9z. And 4 times 9 is 36. I'm going to combine these and get a 13z. And that's exactly the original problem. You can't see anything I just did. I did my foiling, z times 9, 4 times z, 4 times 9. That's the multiplications with the signs between, and then I added the 4z and the 9z. Matches the original problem perfectly. Let's skip 11 and move on to the stuff that I want to get to now. The next group of signs. If I have a plus sign first and a minus sign second, the factors need to be plus and minus, and the bigger number is going to get the plus sign. This is a big deal. So when I get to problem 14, the last number is -6. I need to find numbers that multiply to -6, and the middle coefficient is 1. Technically, they need to add to 1, but this adding is going to be more like a subtracting because the signs are different. So I'm going to write the factors of -6, one positive and one negative. In order to multiply to a negative, you need one positive and one negative, and the big number is going to get the plus sign. So I'm going to do 6 times -1. That's positive times a negative, multiplies to -6. Big number is plus. And 3 times -2, positive times the negative, multiplies to -6. So those multiply to -6. Now let me add these. I'm going to go 6 plus -1 and 3 plus -2. This is really where the word add is kind of almost a misnomer, because when I do 6 plus -1, well, it turns out to 5. It's really subtracting. If you're adding and the signs are different, you're subtracting. And similarly, 3 plus -2, that comes out to be 1. Sometimes, instead of saying they have to add, I say they have to subtract, because they really, in some sense, subtract. So this is clearly the pair I'm going to need, because those multiply to -6, they subtract to be 1. And when I rewrite the positive 1x, I'm going to write it as -2x plus 3x. I'm going to write the negative first and the positive second. It's going to make my work easier. I could have written 3x minus 2x, it'll make the grouping factoring harder. So -2x plus 3x is equal to 1x. So I'm allowed now to rewrite the problem with x squared minus 2x plus 3x minus 6. Choosing to write the the middle terms this way makes it so the grouping is easier. Now I have 4 terms. I'm going to do my grouping. First 2 terms, I'm going to pull out a factor of an x and be left with an x minus 2. Second 2 terms, I'm going to factor out a 3 and be left with an x minus 2. Now I'm going to write the common parentheses, followed by what's in front of the common parentheses, and that's an answer. Equivalently, I could write what's in front of the common parentheses, followed by the common parentheses. Both equally correct answers. And this video is droning on, so I'm not going to check. The last situation is a minus minus, which I should have written down here. I already had a minus plus up there. If I have a minus, and that's what I have in problem 16, the signs, the factors need to be plus and minus, but the small number gets the plus sign, and the big number gets the minus sign. So what do I mean by that? Well, let's look at problem 16. I know my numbers are going to have to multiply to -6, and they're going to have to, I'll say quote unquote add. The adding is really going to be subtracting. They have to add to that coefficient, which is an implied -1. I'm going to find the plus minus numbers that multiply to -6. The small number is going to be plus, the big number is going to be minus. So I'm going to do 1 times -6, that's small number plus, big number minus, that multiplies to -6, and 2 times -3, small number plus, big number minus, multiplies to -6. Now I'm going to add these. I'm going to go 1 plus -6, and 2 plus -3, trying to get -1. 1 plus -6 is -5. This is why I put adding in quotes, because it's really subtracting. This is really 1 minus 6. And 2 plus -3 is -1. That's the pair I'm going to need. I'm going to break up this -1x into 2x minus 3x, or I'm going to break the -x into -3x plus 2x. Both of these are acceptable. Both have a +2 and a -3. This is better. When you have a minus and a plus, it's better to put the minus first and the plus second. So I'm going to rewrite the problem. Instead of having the minus x, I'm going to write minus 3x plus 2x minus 6. If I would have flip-flopped it, I'd get the same answer. It's just I'd have to factor out a negative in the grouping, and I don't care to do that. Probably write an equal sign because this equals the line above it. So parentheses, parentheses. First parentheses, pull out a common factor of an x, left with an x minus 3. Second parentheses, pull out a common factor of a 2 and be left with x minus 3. And then there's 2 possible answers. I don't have enough room, so I'm just going to write the 1 with the common parentheses first, and what's in front of the common parentheses second. But you can flip-flop and say x plus 2 times x minus 3. That would be fine. I covered up 18, so let's do 17 together. So for 17, I'm looking for numbers that multiply to -12, that quote-unquote add but really subtract to be 4, and the big number gets the plus sign, the small number gets the minus sign. So when I write down the factors of 12, which are 12 and 1, 6 and 2, 3 and 4, I'm going to do +12, -1, +6, -2, +4, -3. So the factors, the numbers that multiply to -12 with the big number plus, small number minus, are 12 times -1, which I could yank off this sheet, 6 times -2, and 4 times -3. From these pairs, I need to add these, and the adding is really subtracting. I'm going to add 12 and -1. I'm going to add 6 and -2. I'm going to add 4 and -3, and try to find the pair that gives me 4. So 12 plus negative 1 is 11. 6 plus negative 2 is 4. And 4 plus negative 3 is 1. I need this pair because that does both. And so this 4x, I need to write it as 6x minus 2x. I don't like that because I like the negative to be first. So I'm going to write the 4x as negative 2x plus 6x. So rewrite this problem as x squared minus 2x plus 6x minus 12, parentheses, parentheses. Inside the first parentheses, I'm going to pull out a common factor of an x and be left with an x minus 2. Second parentheses, pull out a common factor of a 6 and be left with an x minus 2. Then I like to write the common factor followed by what's in front of the common factors. That's what I generally do, but there's definitely a lot of students that will do the reverse, write what's in front of the common factors followed by the common factors. I think I'll do like 4 more problems, maybe 3 more problems, because this part of the video is getting a little bit long. And I'm at a good place right here because I'm getting to the part that's going to go quick. Let's look at 22. For 22, I need plus plus numbers that multiply to 2 and add to 5. Because the signs in the original problem are plus and plus, the numbers I'm looking for are plus and plus. So the factors of 2, the numbers that multiply to 2 are only 1 and 2. Now I'm going to add those numbers. Those are the only numbers that multiply to 2. Those add to 3. The only choices to break up the 2, the only numbers that multiply to 2 that are double plus are 1 and 2. Those don't add to 5. I can't find a pair of numbers that do what they need to do, multiply to 2 and add to 5. That means the polynomial can't be factored. We say that the answer to this is prime, meaning it can't be factored. Similarly, on problem 24, the original problem has a minus and a plus. I need minus minus numbers that multiply to positive 2. What I'm searching for are numbers that multiply to positive 2 that add to negative 5. So I'm going to do the double negative numbers that multiply to negative 2. That's negative 1 times negative 2. Those multiply to positive 2. Now I'm going to add these. I'm going to go negative 1 plus negative 2. And negative 1 plus negative 2, well, that's negative 3. The only candidates I have that multiply to positive 2 that are double negative, they don't add to negative 5. There's not a pair of numbers that can simultaneously multiply to 2 and add to negative 5. That means that this can't be factored in its prime. Number 26, when I break up, it's a plus minus because the signs are plus and minus. When I do the factors, I need plus and a minus, big number plus, small number minus. I'm looking for numbers that multiply to negative 11 and that quote-unquote add, but it's really subtracting, to 2. Big number plus, small number minus. So 11 times negative 1 multiplies to negative 11, but 11 plus negative 1 doesn't add to 2. So the only choices that can possibly multiply to negative 11 and fit the signs that I need don't add to be 2. So this one's also prime. There's no pair of numbers that do both things simultaneously. Multiply to negative 11, big number plus, small number minus, add to 2. It's really subtraction here. When the signs are different, the adding is net subtracting. And then the last problem I'll do is problem 28. It's a double negative, so I need plus minus factors. Small number gets the plus, big number gets the minus. So I need numbers that multiply to negative 11 and really subtract to negative 2. And they have to be double minus. Whoops, I made that wrong actually. They're plus and minus. This one is a minus minus, and in a minus minus you need plus and minus, small number plus, big number minus. I kind of messed up there. So for this one, the numbers I need to multiply to negative 11 are 1 and negative 11. That's small number plus, big number minus. Those multiply to negative 11. And if I add these, 1 plus negative 11, it's really subtracting because the signs are different. 1 plus negative 11 is negative 10. The only numbers that satisfy multiplying to negative 11, small number plus, big number minus, don't add, quote unquote, really subtract to the middle number, so that's also prime. There's no way to break it up into 4 terms successfully. Okay, let's stop the video and move on to a part 2.